Hello everyone, welcome back to Fun with Stewie. And just so you know, I've renamed my channel to Rum Hacking with Stewie. And just because for YouTube algorithm, it's easier to have one channel dedicated on one topic, and it makes the search faster and more efficient. So this channel will be dedicated only on rum hacking with Python. At some point, I might have another channel for Power BI and BI stuff. So let's see. If you recall what we have done last time, we played with Super Robot Wars Alpha 3 on the PS2 with the PCSX nightly emulator. And we used the memory option to find some text in memory on the game. For the game. So we can take a screenshot of our text, go in Google Keep, grab the image text, and from there we get the ShiftGIS bytes. And when these bytes, we can go on the debugger, open debugger, memory watch, area of byte. We put some zero to reduce the match, and then we have a bunch. We try the first one, double click, and then it shows a zero here, so we can adjust the bytes. So what I've done last time is I just put the same bytes for the second character, and I hope to see the same character. So you see I've changed this string. Sometimes, depending on the text, you might need to change menu and come back, and this will update the text. Like the draw routine might be triggered by something else. But yeah, so we have found that the same text in memory. This is the memory address, and we said that the same text, we were able to find it in the SLPS file on the ISO. The SLPS is the main executable. It contains a lot of code and also bunch of text for the menu. With the XHD, we were able to find some text here. And since like we have the first occurrence was the one we are interested, it's the first in the sequence in order. So if I find the same match, I know that the first one will be my text that I'm looking for. We also said that there are a couple of ways that PS2 can refer to text in memory. And one of the method is the relative pointers. So today's video will be about relative pointers. I can tell you right now that this game doesn't use a lot of relative pointers, so I might have to change to a different string, but it should not stop us from doing a bunch of stuff. So first, before we start, I just want to mention for those that are new to the subject, you should watch the videos by Iltop. Iltop is a known ROM hacker. He's really good. He have worked on a lot on translation. And this video, what it takes to fan translate a video game, 32 minutes. It tells you like everything you need to know uh, if you want to get into the subject. There's a lot of things in this video. I really recommend you to watch this video if you're interested in the subject. You will understand a lot better some of these concepts, and he probably teach the concepts better than me. So you should watch this video. I think he has like 5 or 6 of them, and it's very nice to watch. So Hilltop, yeah, you should watch it. And then, okay, so relative pointers. So basically, if text is a reference using relative pointers in a game. It means that instead of the game trying to access a specific address where the text is stored, the game will reference to a pointer, and this pointer will be pointing to this address. And usually the pointer will be based on the memory address. So if we said last time that PS2 is using little endian to store and read the address. So if my address, if we take this address, let's go with this option, this address 4E B0 90. This one is my memory address. For the pointer will be, sorry, I have a problem. Pointer. For the pointer, it will read it, it will write the pointer, like the pointer will be stored in the reverse order. So you take each bytes and you reverse the order. I will put some space just to help. So this will be how the pointer will be stored. And since PS2 pointers are stored using 32 bits, it will use 4 bytes. So it will have ending 0 like this. For this text, I'm pretty sure it's not using relative pointers. And one way to know if it's like that is to try to find this sequence for the pointer in the HXD on the SLPS. So if I search for this sequence, 222 B0, I can only put the first one, and I don't find any match, which is sad. So it means this text is referenced using a different method. And since the pointers will be based on where the text is stored in memory, you see a bunch of text is in the range of the 4E. So I would expect to see a bunch of pointer that ends with 4E or maybe 4F. So if I go and I look in this, maybe if I search for a 4F 0, because like I said, on 4 bytes, it will probably end with a 0, and I look for match, I might find interesting stuff. So I have a bunch of things here, and it might be easier to search with that. Usually pointers are more like in the meh, not exactly what I want. Okay. Oh yeah, this is better. This is better. So you see, I found some. Usually it's not like this that you search for pointers, but so if we take these, you see they are all ending with a 00, and they are following a very similar pattern. So, and this is probably like a small pointer table. So each of these looks to be like pointer. And the last one will be probably this one because we only have 0 and bunch of stuff that doesn't seem to be really interesting. But if we take the first one, like we said, pointer will be, in that case, pointer will be stored relative to the address in memory. And if we want to know what text is it, we can look at it in memory, but we will need to reverse this sequence. So reversing that would be 4FDE00. So if we go on the debugger, 4FDE00, FDE, it gives us this. So you see, the text starts here, and there's a bunch of 0 here telling me that this is the start of a new string, and so we can confirm this is a text, and it looks to be like a Shift.js, so it seems to be normal text. So we could just take these bytes and manually type it over HXD and trying to find the same text, but inside our file. We see we have a match over here, and we have one match actually. So, and we can confirm that we see like the same blah blah blah, the same 78 B1 to F. It's just a little bit different, but you know, it's the same. And the same 96 BD is right underneath. So we have some text here in the file, and we know this text was stored using a relative pointer. In our pointer, we said it was this, no, not this one. We said, so let's take some note because we might need it at some point. So what I usually do, I always have a, you can work with different things. I like to work with the Google Doc. So let's create a Google Doc for what we do. Let's have a small Google Doc, and maybe we create a section, and then from there we could just to help, let's write the text. So we said this one, let's see, what text is it again? It's the text that starts with 8B, if I recall. 8B, this text. So maybe I'll just try to see X to Shift.js. What's this text? My bytes is that. My text is that. And what I like to do is to type memory address or offset. Memory offset is the position location in memory for FDE. Sometimes you can put 0x just to mention this is x in hexadecimal, and then file offset. This is my position in the file, so 3ffd00. And we could also write pointer offset. So pointer offset is basically where the pointer is stored in the file. So I just reverse the bytes like we said. We would search for DE4F00 if I recall. Yeah, and we have 0 here. Yeah, this one. That's interesting. So this one is really interesting. So you see, we have twice the same text that is referred. So both of these, they point to the same text, but it might be used in different section of the menu. So in that case, it will just reuse the same text. So in that case, we have two pointer offset. We have this offset, like the possession. I take take the first 3C 9C. And our second one will be 3C 9C 38. That's good. So we now something that we can do is sometimes you will just find you will looking at the file, and you will find these pointer tables, and you will start to be getting good at identifying what seems to be a pointer table. And you just want to see, okay, like this seems to end here. This is miscellaneous stuff I don't need. Maybe I want to see like the last one in the chain. What is it? So I can write this like this address. I reverse the bytes, and I will go in Excel, and I will just have a memory. I put some tabs. I have memory, file, and sub. So for F DE98. And for this one, let's first write the other one, sorry. Let's first write this one. We said for this one, our memory address was that, and the file was 3FFD00. This is very important because with that, you can calculate what's the base address of the SLPS, or basically where the SLPS file is loaded in memory. So what I do is I just take the memory offset, file offset, and I convert this to decimal, and then I subtract each of them. And this will tell me, like this one will be in decimal, and I do this to X to convert it back to X. So it tells me that the SLPS seems to be loaded at FE100 in memory. And this one is very important because I will use it. I will use the decimal here just because it will be easier for calculation. But if I know where the SLPS is loaded and where it starts in memory, I can do the reverse operation and say, okay, I have something. I have this string here that I know is at 4FDE98. This is my memory, and I want to get the file. And as you see, the file is always lower than the memory in that case. So I can take this memory and I can subtract. I convert it to decimal first, and then I subtract my base address and I convert it back. And this tells me this is the file offset for this text in memory, referred to this pointer. So if I can do, I can save, Control Shift 1 to save. It will probably not work because I'm using Zoom it, but anyway, I can go at this 3F and it will tell me that it's this text. It seems to be right. It's a new text, only one character, it seems. And for our text previously, we said it was at 3FF D0. D0 is right here. So maybe what we have is actually all the text between the start that is here and the end section that is here. That's what I suspecting with my pointer table that we found. So now what you will do is, since you have identified a section of the SLPS file that is using relative pointers, so in our case it's relative to the address in memory. So now that you have identified this, it's using relative pointers, we can work with this pointer table that we found and extract this text. And while we extract the text, we will store each of the pointer offset. Because so what's happening is, let's see that this is all text. If we extract this text that starts right here, this text ends here. There are a couple of buffers of 0 that are added here. that we can use, but the next sentence starts right here. If we need to replace this text in Japanese by some English text that is longer, we don't have a lot of space. And if we start and we write over this text, then this text that is being referred by another pointer will be looking at garbage text that is from the first string. So it's very important when we extract text, we need to store what types of pointers it is using. And in our case, if it's using relative pointer, we need to know like this text, where is the pointer in the file, so that when we reinsert the text, we will update the pointer to look at the different place. So if we do the we can do some exercise. Let's do something. Okay, it will be fun. Let's try something. So we have our text. Yeah, the problem is we don't know where it is in memory. We just find unknown text that we don't know where is it. So this might be difficult to test. But yeah, let's not do that for now. So since the video is already starting to get long, I think it might be better to start another one. And we will now do the next part in Python. And in Python, we will be, if I look here, in Python, we will be looking at this pointer table that is relatively small. We will extract all of these pointers and in Python, we will extract the text. Let's try that. And hopefully it works and we don't have any problems. So we will see each other in the next section, next video. So thanks again. Have a great day. Bye-bye.